Tuesday, June 2nd, 2015 examination. Let's go ahead and look at the questions. Okay, for part 1. Which object is formed when the right triangle, RST shown below, is rotated around leg RS? So what we want to do is we want to rotate this leg RT around RS. So the image that we will get will be another triangle on this side. Now, when we're rotating it, we're going to have this wonderful shape formed. So in other words, this shape, if I rewrite it here, will look exactly like this. And that, if you're familiar with, is termed the word cone. So this is a geometric shape known as a cone. So therefore, choice 4 is the correct answer. So that's what will happen if you rotate it around leg RS. Okay. Question number 2. The vertices, in other words the corners, of triangle JKL have coordinates 5, 1 for J, -2, -3 for K, and -4, 1 for L. Under which transformation is the image triangle J prime, K prime, L prime not congruent to JKL, triangle JKL? Okay, for something to not be congruent, so the emphasis on the word not, you would not be keeping the shape of the object. So translation preserves, so this is not it. Rotation counterclockwise also preserves, so this is not it. Reflection preserves shape and size. The only thing that does not preserve is a dilation, because what would happen is that it will no longer be congruent. So if we had, say, this triangle, a dilation of some factor, let's say, I don't know, 2, right, for example, would make the object much more greater. So that would mean the side JK is not the same length in terms of distance to the side, to the dilated side JK, J prime, K prime. So choice 4 is the correct answer here. Question number 3. The center of a circle Q. Let's draw a circle. In that center, we have the letter Q. We call circles by their center, whose coordinate is -3, +3, -2. If the circle passes through the point R, 7, 1, so here's a point that it passes through, we'll call that point R, and the location of that point is in some space at 7, 1. We want to know what the length of the diameter is. Well, what we could do is we can first figure out the length of the radius. And the way we're going to figure out the length of the radius is we're just going to take the distance formula. So for those of us who don't recall what the distance formula is, let's reiterate what the formula is. So it is x second minus x first, so the second x coordinate minus the first coordinate squared, plus the second y coordinate minus this first y coordinate squared. So if I plug this in, I get the following. X second would be the point R, 7 minus 3, plus y2 minus y1 would be 1 minus -2 squared. So the distance is now the following. It is 7 minus 3, which gives us 4, plus 1 minus -2. So a negative and a negative will become a positive. So what we have here is rather 1 plus 2, which gives us a value of 3. Then we square that. The distance of that is now the sum of the square root of 16 plus 9. So the distance is equal to the square root of 25, and the square root of 25, since it's a perfect square, comes out as 5. So we have the distance of 5 units. So the length from here to here is none other than 5 units. Now we know that the diameter is always twice the radius. So if the radius is 5, then the diameter from here to here must be 2 times 5. So 2 times the radius, which means 2 times 5, would give us 10. Therefore, choice 3 is the correct answer. Let's go and look at question number 4. In the diagram below, congruent figures 1, 2, and 3 are drawn. Which sequence of transformation maps figure 1 onto figure 2 and then figure 2 onto figure 3? Well, to go from figure 1 to figure 2, notice that all you did was you just moved the object. In other words, you've translated it. Right? A motion of an object moved from one side to another is called a translation. So let's look at the choices. We have, so everywhere where we start with translation, it would be the correct one. So it's not a reflection. It is most certainly not a rotation. It is a translation, but 2 of the choices have the word translation. So let's see how we go from step 2 to step 3. So notice that A is located here, but then A is located there in number 3. So what we had is a rotation. The object in 2 rotated to get to the position in 3. So therefore choice 4 is the correct answer. It is in fact not a reflection, but rather a rotation. Let's go to question number 5. As shown in the diagram below, the angle of elevation, so this angle right here, from a point on the ground to the top of the tree is 34 degrees. If the point is 20 feet from the base of the tree, so this distance is 20 feet, because it's from the base of the tree. What is the height? I want to know the height of this tree, so let's call that x. So what do we have? We are looking for opposite over adjacent, so that's the tangent. So the tangent of 34 degrees is equal to the opposite over the adjacent. Well, by mere cross multiplication, I will get that 20 tangent of 34 is equal to x. And if you calculate this correctly, the value of x is roughly 13.5, which makes choice 3 the correct answer. Let's look at question number 6. Which figure can have the same cross-section as a sphere? So let's go ahead and draw a sphere. So a sphere is like a beach ball, in which if you would take a cross-section, so let's go ahead and take a cross-section. Let me just take a cross-section like this. Imagine I'm cutting it like this. This yellow portion, this cross-section, is nothing other than a circle. So which of these 4 choices, if you would take a cross-section, would give you a sphere? That would give you a circle. So that would be a cone, because look, if you cut a cone, the shapes inside always form circles, because the base of the cone is a circle. So it would always form circles if you cut it at a certain angle. It will not, for choice 1, you have a rectangular prism. No matter how you cut it, you'll not get a circle. Same thing with the square pyramid, and same thing with this frustrum. So choice 2 is the correct one. Number 7. A shipping container is in the shape of a right rectangular prism. Now sometimes it might help to draw these objects. It's not necessarily always the case, but sometimes it might help. So if I drew the right rectangular prism, so that's something like this. And the shape is interesting in that the dimensions here is 12 feet. So let's go 12 feet by 8.5 feet by 4 feet. The container is completely filled with the contents that weigh on average 0.25 per cubic foot. What is the weight in pounds of the contents in the container? So first of all, let's go find the volume of this shape. So the volume of a rectangular prism is just the multiple of all its sides. So we have 12 times 8.5 times 4. And then of course, we're gonna divide everything here by 4. And why are we dividing everything here by 4? Because it says on average 0.25 pounds per cubic foot. So 0.25 is the same thing as saying 1/4. So I'm dividing everything here by 4 because in essence it can also be said that I'm multiplying everything by 1/4. So this is the same thing as saying 12 times 8.5 times 4 times 1/4. It's the same exact thing. So this 4 cancels out with this 4. Then 12 times 8.5 is just 102. In the diagram of a circle A shown below, chords CD, so this chord right here, CD, and EF intersect at the point G, such that chords CE and FD are drawn. So CE and FD are drawn. So the ones that are in, so those chords are drawn. I'm just going to draw them in magenta so we see the chords that they're referring to. Those are the chords. Okay, which statement is not always true? So let's look at choice 1. CG, this length CG, is congruent to FG. Well, that's not always the case. It's not necessarily always going to be the case where CG is going to equal to FG. So for now, this is the only one that is not always true. Let's look at the other choices. The other choices say angle CEG, so this angle here, is congruent to FDG. That will always be the same angle because they intercept the same arc. Angles that intercept the same arc will be the same degrees. So this is not it. What about CE over EG? So CE over EG is the same thing as FD over DG. That's actually going to be true because these two triangles are similar to each other because they have two sets of angles that are congruent to one another. And in order for two triangles to be similar, you only need two angles from both triangles to be the same. So these two triangles are actually similar to one another, so this is always true. And we're looking for something that's not true. So choice, they're both similar, and if they're similar, you can write them in proportion. So this will also be true. The only one that's not true is the chord CG congruent to FG. Okay, number 9. Which equation represents a line that is perpendicular to the line represented by 2x minus y equals 7? So what you first want to do is you just want to rewrite this equation in the form y equals mx plus b. So you can do that simply by adding y to both sides. So this will cancel. You will get 2x is equal to 7 plus y. And then go ahead and subtract 7 from both sides. So this will cancel. You'll get that 2x minus 7 is equal to y. So I'm just going to put the y in the front. So the slope here is 2. We want to look for a perpendicular. So that means we need to find the slope perpendicular to that. So the slope perpendicular is the negative reciprocal. So the negative reciprocal is just negative 1/2. So we're looking for an equation that has a slope of negative 1/2. The only one that has it is choice 1. Okay, number 10. Which regular polygon has a minimum rotation of 45 degrees to carry the polygon onto itself? Okay, so in order for a polygon to carry onto itself, what you need to do is you need to take 360 degrees. You need to divide it by the number of sides of that polygon, and then see if it has a multiple of 45. But we need a minimum of 45. So let's try with an octagon. So an octagon is an 8-sided figure. So 360 divided by 8. That gives us 45 degrees. So that is the correct one. An octagon. In the diagram, triangle ADC below EB, this line is parallel to DC to that line. If A is 9 and ED is 5 and AB is 9.2, what is the length of AC, the whole segment from here to here? Well, let's call this Y, but we don't know BC, but we can make a proportion, right? Because we have two sides inside the triangle parallel to each other. So we can say that 9 over 5 is equal to 9.2 over x. What that means is that I can multiply, cross multiply, and I get that 9x is equal to 9.2 times 5. Then I can go ahead and divide both sides by 9 to get x by itself. So I get the value of x is equal to 9.2 times 5 divided by 9, which, if you open carefully, will give you the value of roughly 14.3. So for number 11, we have a value of, we have a value of 5.1 for x. This is 5.1. Right, because 9.2 times 5, so that's 46. 46 divided by 9, that gives you 5.1. So what you have here now is you need to find y. So the value of y is equal to 9.2 plus x. So that's 9.2 plus 5.1, which gives you 14.3. So choice 3. In a scalene triangle, so scaling means that none of the sides are the same. So this side, and this side, they're all different. None of them are equal to each other. X, Y, Z, none of them are equal to each other. They're all different size. Measure angle C is 90 degrees. It's a right angle. So what is always true? So does the sine of A equal the sine of B? Well, let's see. The sine of A is equal to opposite, which is y, over hypotenuse z. So we get y over z. The sine of B is equal to opposite or hypotenuse x over z. This is supposed to be z. So you see that y over z is not the same thing as x over z. So 1 is not it. Okay, what about choice 2? Cosine of A is equal, so the cosine of A is equal to the cosine of B. Let's see, the cosine is the adjacent over the hypotenuse, so x over z over the cosine of B. Cosine of B is y over z. So that doesn't work. Okay, number 3 says the cosine of A, which we already know is x over z from question 2, is the same thing as the sine of C. Well, the sine of C is just the opposite over the hypotenuse, just z over z. So that doesn't work. Then we have number 4, that the sine of A, which is y over z, is the same thing as the cosine of B, which is y over z. And that's true. They're both y over z. So choice 4 is the correct answer. Okay, number 13. Quadrilateral ABCD. So here's a quadrilateral ABCD. We can label it. Has diagonals AC and BD. Which information is not sufficient to prove that a triangle ABCD is a parallelogram? So if AC and BD bisect each other, then that would be sufficient to prove that it is a parallelogram, because that's one of the properties of a parallelogram, that diagonals bisect each other. If AB is congruent, so they're now saying AB is congruent to CD and BC is congruent to AD. If that is true, then the case is that it will be a parallelogram, so this works also. In other words, these will be sufficient. Okay, AB is congruent to CD, so AB, this side, is congruent to CD, and also AB is parallel to CD. If you have two sides, if you have one side that is congruent to itself and also parallel to itself, it's sufficient for it to be a parallelogram. Now, what it would not be sufficient if I had this one congruent to this, if one side is congruent to another and the other two sides are parallel to each other, like in this scenario. So in choice 4, AB is congruent to CD, but BC is parallel to AD. If you have one side congruent to another and the other side is parallel to another, it doesn't prove that it's a parallelogram. So choice 4 is the correct answer because it's not sufficient. Okay, number 14. The equation of the circle is given to you here. What are the coordinates of the center and the length of the radius of the circle? Okay, in this type of question, what you really want to do is you want to use the completing the square method. So let's use the completing the square method here. So first of all, I'm going to rewrite this as x plus 0 squared plus. Now, in order to use completing the square method for this region right here, you have to take the second term in the y, which is 6y, divide the coefficient 6 by 2, which gives us 3, and then square it. So that gives you 9. So you're going to have y squared plus 6y plus 9. But you have to remember that whatever you add to this side of the equation, you also have to add to that side of the equation. So you're going to have 7 plus 9 here. Now we can condense it further. We have x plus 0 squared plus And I'm going to rewrite this as y plus 3 squared equals to 16. Now, remember that this number here is actually the radius squared. And the HK is the center of your circle. So here you have 0, 3. So your HK will be the opposite of those numbers. So 0, and the opposite of positive 3 is negative 3. So that's the center. And then the radius is just the square root of r squared. So it's the square root of 16. So that gives you 4. So it would be choice 2. Okay, number 15. Triangle ABC and DEF are drawn below. If AB is 9, so this segment here is 9, and BC is 15, DE is 6, and EF is 10. And they also tell you an interesting information that angle B is congruent to angle E. They don't tell you it's a right angle, they just tell you that they're congruent to each other. Which statement is true? So angle CAB is congruent to DEF. Is that necessarily true? We don't know anything about those two angles. So this angle being congruent to this angle, that's not said in the problem. And we don't know that this is an isosceles triangle. If this triangle ABC was isosceles, then A would be congruent to E. But that's not the case, so choice 1 is not correct. Choice 2. AB over CB, so they're saying 9 over 15 is equal to FE 10 over 6. Now, that's clearly not the case, because if I reduce both of these formulas, I get 3 over 5 equals 5 over 3. So that's not going to be the case. So this is not it either. Now, are these two triangles similar to each other? Well, let's see. Can I write a proportion? Let me see. If I write the proportion AB over BC, and I say that that's equal to ED over EF, so that would be 9 over 15 is equal to 3 over 5. Is equal to 6 over 10, which makes these two true. And if I can write those two in the statement are equal to each other, that means those two are similar. So that's true. If these two triangles are similar, then I can write their terms into proportions. So AB over DE, so 9 over 6 is equal to FE, which is 10 over CB, 15. This makes sense. This makes sense. So choice 4 makes sense. I don't know about choice 3. Can't necessarily do that. Choice 4 makes sense. If triangle ABC is dilated by a scale factor of 3, which is true, so you're going with A, B, C, and then you're dilating by a factor, let's say, of 3, which it says over there, and you have this image, A prime, B prime, C prime. The one thing you need to know is that all the angles are going to be the same. So the angle for A is going to be the same as angle A prime. All the angles are going to be the same. The things that are not going to be the same is the side. So if this side here was x, this side would be 3x. So 3 times A prime, B prime is going to be AB. No, that's not true. As a matter of fact, the other way around would be true. B prime, C prime, so B prime, C prime, is actually 3 times this side. So this choice 2 is correct. Because the bigger triangle is 3 times the smaller triangle. This here is the smaller triangle, this is the bigger triangle. So the bigger triangle is equal to 3 times the smaller triangle. Okay, Steve drew a line segment ABCD, EFG, BF, and CF are as shown in the diagram below. You have a scalene triangle here that is formed, which statement will allow Steve to prove that this line here is parallel to that line. So let's see, angle CFG, so CFG, this angle here, is congruent to FCB, this angle here. Yes, that's actually will be the case because those two are called alternate interior angles, and that can only happen is if you have two parallel lines that are cut by a transversal. If you have two lines that are parallel to each other cut by a transversal, then this angle will always be congruent to this angle because of the idea known as alternate interior angles. So therefore, that's all you need to show. Number 18, in the diagram below, segment CD is the image of AB after dilation, scale factor K with center E. Which ratio is equal to the scale factor K of the dilation? So let's look at the choices here. We have EC, so this over EA. Yeah, that is exactly it. It's choice 1. It's this from the center is E, so the distance from EC over EA over the whole length is the scale factor. Okay, number 19. A gallon of paint will cover approximately 150 square feet. An artist wants to paint the outside surfaces of a cube. So we're talking about the surface area of a cube. So let me just draw a cube here. Here's a cube, more or less. And we just want to get the surface area. So what's the surface area? So the surface area is just the area of a square, right? So these are all the same sides. So the area of a square is s squared, but we're looking for surface area, and there are 6 sides to a cube, so it's 6s squared. Okay, so let's see what we have here. Measuring 12 feet on each edge. So these are all 12, 12, 12, and so on and so forth. So just get the square. So we have 6 times 12 squared. Okay. What is the least number of gallons of paint he must paint the cube? So let's look at this very carefully. So we have 12 squared is 144. So we have 6 times 144. So if we take 6 times 144, we can do this the long way. And if you guys don't have a calculator on, you can just do it the long way. So 6 times 4 is 24. So place the 4 carry over the 2. So I'm just doing this for you guys so that you guys can see, so that you guys know exactly what it is that we're doing here. So 6 times 1 is 6, so you get 864. Now you're going to take 864 and you're going to divide it by 450. Now clearly you're going to get a number less than 2. You're going to get some number less than 2. So 1.9 something, right? So, but you need the least number of gallons, so you get 2. Okay, number 20. In a circle O shown below, diameter AC, so we have this diameter right here, AC, is perpendicular to CD. That means you have a right angle being formed here. At point C, and chords A, B, B, C, A, E, and C are drawn. Which statement is not always true? So let's look at the knots. Angle ACB, so this angle is congruent to BCD. So right off the bat, this is not always true. The reason why this is not always true is because the chord BC could be particularly anywhere, right? So it can be such that this is 30 and this is 60, or this could be 45 and that's 45. So right off the bat, this is not always true. But let's go ahead and look at the other stuff. Okay, so if I look at the other stuff, the other stuff are the following. So number 2, ABC, so this angle right here is going to be congruent to ACD, this angle right here, and that's going to be true. The reason why that's going to be true is because this angle here is a 90-degree angle. How do I know this 90-degree angle? Because it is 1/2 that arc, and this arc is 180 degrees because that's the diameter. That's the arc that goes from point A to point C, so half of that would be 90. But this is perpendicular to CD, so therefore this is 90, so this is true. Okay, number 3, BAC, so BAC, this angle here, is congruent to DCB, to this angle here. Well, let's see. They intercept the same arc, so therefore their angles must be the same. ABC intercepts arc BC, and BCD, or rather DCB, intercept the arc BC. So because they intercept the same arc, they're the same. Okay, CBA, so we have CBA, C, B, and A. So again, this angle here is congruent to AEC, this angle here. So this angle here intercepts arc AC from this side, which is 180 degrees, which makes this angle a right angle, 90 degrees. And ABC intercept the arc AC, which makes this a 90 degree angle. And right angles are congruent to each other, so choice 4 is also always going to be true. The only one that's not going to be true is choice 1. Number 21. If AC, in the diagram below, triangle ABC is similar to DEC, that means their angles are the same. So in other words, this angle is going to be congruent to this angle, B is going to be congruent to E. So similar, in other words. Or it could be that C is actually congruent to this side. Well, actually, to be honest with you, that even makes more sense, because they both have C, so you have these two angles that are going to be the same. So then you have 12 here, and you have 7 there, and you have 5 here. You know that the perimeter of ABC is 30. You want to know the perimeter of DEC. So what are you going to do? Well, let's see. You can take 7, which is DC, divided by AC, because you can write the number proportion, and then multiply that to 30. So I'm just going to simplify 30 and 12. So you divide top and bottom here by 6, so you get 5 and 2 here. Now 7 times 5 gives you 35, so you have 35 over 2. 35 divided by 2 is 17.5. So for 21, you should get choice 4, 17.5. Number 22. The line 3y equals negative 2x plus 8 is transformed by a dilation centered at the origin. Which linear equation could be its image? So first of all, rewrite this equation in standard form. So if I write this in standard form, I'm just going to add 2x to both sides. If I add 2x to both sides, this guy cancels, so now I get 2x plus 3y equals 8. So I just need to find another equation that starts with this standard form, and that's choice 1. Because the dilation only increases the line, but it doesn't change it. In other words, it doesn't morph it, like it only makes it either bigger or smaller. But an equation of a line is infinite, unless given boundaries. 23. A circle with a radius of 5 was divided into 24 sectors. The sectors were rearranged as shown in the diagram below. To the nearest integer, what is the value of x? So this here is the length. But they're not asking for this side. They're only asking for this side. So what do? They took the circumference of the circle, broke it up in half, and then only took this segment and asked for x. So we know that the circumference is equal to 2 pi r, right? They told us that the radius was 5. So we have the circumference equaling 2 pi times 5, which is just 10 pi. But we know that pi is nothing other than 3.14. So this is just 10 times 3.14, which just gives us 3.14. Now what we have to do is we have to divide it. This is for the whole circumference, but we only want to find half of it. So we're just going to divide this number by 2. So if you divide this number by 2, you're going to get 15.7. So 15.7 to the nearest integer gives you 16. So the answer here is 16. Okay, number 24. Which statement is sufficient evidence that triangle DEF is congruent to triangle ABC? So AB is congruent to DE, it's choice 1. So they're telling you AB is congruent to DE, and BC is congruent to EF. So that's not sufficient because this only tells you 2 sides. It doesn't tell you anything about the third side, so that's not true. Okay, now with yellow, angle D is congruent to angle A, angle B is congruent to angle E, and angle F is congruent to angle C. So first of all, this just tells you that these two triangles are similar to each other, but they're not congruent because one can be a dilation of another one. So this does not tell me anything because one of the triangles could be dilated. You know, angles are preserved over dilation, so this doesn't tell me that these two shapes are the same size. Because the dilation makes one either bigger or smaller. Number 3, there is a sequence of rigid motions that maps side AB to side DE, side BC to side EF, and side AC to side DF. Yeah, that's the correct one. There's some sort of sequence of motions that just maps those to that. That's correct. Number 4, there's a sequence of radial motion that maps point A onto point D, point A onto point D, AB onto DE. So this doesn't even make sense. This doesn't even apply. So choice 3 is the correct answer. And so that's it.